This video is going to show us how to fill out this column here that is moles of CO2 collected. This column is also the same column that is here, actual yield, moles of CO2 collected. Okay, so here I have my data for my 3-to-1 ratio. Okay, and I've just kind of singled out these numbers because these numbers are all I really need to calculate my moles of CO2. So to do this, I want to look back at step 4 on page 1. Okay, and this is useful if you don't happen to have your map with you, which I know that the map is sitting in our lockers at school. So step 4, this may look a little bit different than the sheet that you have just because I edited out some of the things. But so we use the ideal gas law, PV equals nRT, to solve for moles, okay? And basically what this is how many moles are in 1 milliliter of gas at 1 atmosphere with our gas constant and our room temperature, okay? And solving this out, we figured out that 1 milliliter of gas has 0.000041 moles of whatever gas we are talking about, okay? And this is specifically for ideal gases, okay, like in quotes, ideal gases. Carbon dioxide happens to be a gas that behaves in this way so that we can use this. Okay, so we have this value, which I'm going to use in just a second. So the other thing we need to think through is the fact that this says milliliters of water displaced, okay? So when we say milliliters of water displaced, milliliters of H2O displaced is equal to is equal to milliliters of CO2 produced. Because remember, our carbon dioxide displaced water, and it's much easier to take a measurement of milliliters of water than it is to take a direct measurement of milliliters of carbon dioxide produced, okay? So because of that, I'm going to actually, when I start using my conversions, I'm going to actually label this as milliliters of CO2 and not milliliters of water. Okay, so I'm going to do the 219 first. Okay, so I always write the number that I'm given, 219 milliliters of CO2. Draw my line like that. So then we have this conversion code. So again, 1 milliliter, so 1 milliliter of CO2 is equal to 0 point and then 4 zeros, 1, 2, 3, 4, 41 moles of CO2. And we solve that out. We end up getting 0.008979. Milliliters of CO2 cancels, and we have moles of CO2. Okay, so that's how you would set that up. You would set up all of these exactly the same way. And I'm leaving 4 digits on there as I'm writing this in my data table. I'm leaving 4 digits on there just because I want to retain as many of those numbers until I'm doing my percent yield. Okay, so for the next one was 215. So for 215 milliliters of CO2, 1 milliliter of CO2 is equal to 0.123441 moles of CO2. And I solve that out and I get 0.008815 moles of CO2. And then my next one was 228 milliliters of CO2 Again, I'm setting this up exactly the same way. 1 milliliter of CO2, 0.123441 moles of CO2. You can see this is super repetitive. And for that, we end up getting 0.009348. Okay, moles of CO2. Excuse me. So I'm going to go ahead and copy these into this data table. So 0.008815, 0.009348. Okay, and then those are the same numbers that are going to go on page 10 in the data to actually include in your lab report. So this is my 3-to-1 ratio, and I have 0.008979, 0.008815, 0.00, oops, too many zeros, 9348.